So for pattern matching, again, we're going to be using regular expressions. Those of you that may have came from another language, this may make a little more sense to you. However, this is one of the more difficult topics in most languages. It doesn't matter what it is, as regular expressions are always a little hard to read, a little hard to understand. And people that do this stuff day in, day out, typically don't know it off the top of their head. It's usually something that they go and look up and use other tools, and we will too. So the way regular expressions work is when we're trying to find something, for example, we have this phone number here, right? And we could create a function called isPhoneNumber, and we would have to do a few checks in order to make sure that this matches. So first of all, we'd want to make sure that it equals at least 12 characters by checking the length of whatever's passed into it. If it's not 12, then we go ahead and just return false. We also then have to do a for I in range of 0 to 3, which means let's take this first chunk of 3 characters, make sure that those are numbers. So in this case, we are using if not is decimal in order to determine that they're numbers. If that passes, then we say if text 3, in other words, if that next part there is a dash, then we go ahead and continue. Then we check the next 3 characters to make sure those are numbers. Then we check for a dash. Then we check for the last 4 characters. If it fails at any point along that way, we go ahead and kick it out as returning false. So it's a really long function there, and we can print different things in there. We can run a function, send a phone number. We can send a bunch of text through, and we would get either true or false back. When we look at the program, we would see something like this, where it's true when we pass in an actual phone number, as we did here, but we would get back false if we tried to pass in a name, for example. Now, while that works, there's some things and some issues as to how that would work. For example, say we had quote marks around the area code, or if there's more than one number inside the sentence, then we'd have to break that up into chunks and find 2 different pieces outside of that. So regular expressions allows us to find patterns of different text. And most of you are familiar with this by just pressing Control F in the web browser, or Control F inside of your Word document or text document. That is a form of regular expression. We are typing in something and we expect the document to find variables of that. So if I do a Control F and say HE, it's going to find me all the HEs in this document. Now, it's not going to necessarily find me the word he. It's going to find me any place that H and E are together in the document. So I would have to write a better expression in order to just get the word he, if that's all I was looking for. And that's what we're going to do with regular expressions, is be able to filter those down and clean that up quite a bit. So when we look at phone numbers, which is what we're going to deal with first here in regular expressions, the regular expression, or the regex as we typically call them, are descriptions for a pattern of text. And for example, a /D stands for a digit character, and that is any single numeral from 0 to 9. So if we had the regex of /D/D/D dash /D/D/D dash, and then 4 more of those, that would match a phone number and do the exact same thing that the entire function did up above. It would check to make sure all those match, and if it doesn't at any point in time, it would fail inside there. We can also be more sophisticated and more tight. So if I zoom in here so you can see it a little easier, you'll notice that by adding a 3 and a curly brace after whatever pattern is basically saying match this pattern 3 times. So instead of having this really long regex, we can actually shorten it to be /D with a curly brace 3, dash /D with a curly brace 3, and curly brace 4 in order to match that exact same format. So for us to use regular expressions inside of Python, we need to import the regex, or the regular expression module. Oops, that was 3.8. Let me go back and grab 3.10 here. So we would import RE just like we would if we were creating a new file. When we brought that in, then we could go ahead and create a regex. So we're going to say our phone number regex is equal to re.compile. We're going to pass it a string. Does anybody remember what the R is in front of a string? This denotes that it's a raw string, so ignore the slashes, in other words. So, or any other escape characters inside of there. So we have this raw string in here for our compile. And if we press enter, now we can try to match against our string that we have here. So we typically call this as matched objects. So a lot of times it's abbreviated as MO equals. Then we take our regex that we just created. So phone num regex. And we're going to do a search through any text that we want to search through. In this case, we're actually going to just type in some text. Something like my number is 415-555-4242. And so we have a piece of string of text and we hit enter. Now, if we look at our MO, we're going to see that it is a match object inside of here. In order for us to look at what we found, we would want to print the group of that. So if we say mode.group, we're going to get back the group that comes out of that, and we would see that it matched to that particular telephone number. So it parsed out of this string that we provided it and just gave us back the telephone number, which is all we wanted. If we follow along with the book here, it basically says, let's go ahead and print phone number found. And that's our mode.group. And then we go ahead and print that out. Whoops, mode.group. There we go. And there you would see that we can actually put that inside of that and concatenate that string inside of there. So again, Mo is just a variable name. It's used for match objects. You can call it whatever you want. It's doing the exact same thing that that function is that we talked about before, and it's searching through that. So the key pieces here are initially setting up our regex, which is using the re.compile. We pass it our regex string up here at the top. In this case, we are matching to those phone numbers like we did before. Then the next piece is we're going to say match objects is to our regex, whatever we called up here, to a dot search, and then we pass in whatever string that we want to search through. It will give us a result as Mo, and if mo.group has anything in it, then we will see that that text comes back. Remember that we could change our phone number regex up here, re.compile. And the shorthand of doing that /d, as we saw, would be putting the curly braces 3 in there. We could have something like this, and it would end up finding the exact same thing if we did a phone number. So if we repeated this search, and then we looked at mo.group, you would see that it still finds the same phone number. The only difference is we have shorthand here to say that we're repeating the same thing 3 times, 3 times, and 4 times. All right, so there's a lot more to do with regular expressions. You can have parentheses and a few other things. If we go back here to Blackboard, I send you a link that's called Regular Expressions 101. And inside here on the left-hand side, you have to make sure you click on Python. And up here is where you can build out a regular expression. So say I took this batch of text right here, and I stuck it into this test string. And I wanted to specifically find the word Python inside of here. I could just type in Python and it would find it. If I wanted to find anything that had the case of NO, it would find me back all the different times that we would see something like that together. If we did SO, let's see here, I'm trying to find something that would actually show multiple. There you go. So you notice if we type in U, or in this case, yo, we would get back the you, and we would get back the first part of your. And we can see those two match cases of information of over here. We can see an explanation up here at the top that we're specifically trying to find at this particular phrase. Down here in the lower right is where you can start working with common tokens and things that we would use in order to encapsulate that. So right now, what you've done is use the parenthesis, or in this case, we use /d, which means it's going to find us any number that's inside this particular string. Remember, we could slash this out just like we did before. And if we look over here at the explanation, it's going to give us a detailed explanation of what is going on. So we're going to match to any digit, any digit, any digit, match specifically to the dash character, any digit, any digit, any digit, dash, and then 4 more times on the digits. So use this tool to help you understand whether or not your regular expression is actually working as you would expect it to. Once you have it working, particularly against some big section of text here, then you can simply copy and paste this out. You can go back into your Python file and you can paste that string inside of where you would do your re.compile. So make sure you use this tool. There's a bunch of things that we're going to talk about inside of here. All right, we can also do a grouping inside of here. So for example, right now when we did a group, we only got one full phone number back. But it would be nice if we could split that up to where we could understand what was an area code, what was the prefix, and what was the number inside of there. So if we modify this just a little bit, this phone number that we have up above, we're going to wrap a parenthesis around these first 3. That will give us back our area code. And if we wrap a parenthesis around the last half, it will actually get us a number. And so this time when we do a search through it with Mo, and we look at mo.groups, we're going to see that we actually get a tuple back because it found 2 matches in there. It has the first match, which was our area code. The second part of this was the actual number. Now, because we have 2 groups inside of Mo, we can call them out independently. So we could say mo.group1 is going to give us back the first index, which is our 415. We could also use 2. We could use 0, in which case it's going to put it all together, which is the equivalent of saying mo.group inside of there. Notice that we're using group here and not groups. So mo.group, we say 0. That gets us back the whole string. Same thing as typing mo.group, gets us back the whole string. If we say mo.group2, if you spelled it correctly, you would get back that last part. Okay? Because we have mo.groups here again, we get a tuple that has both these back, which means we can use our old multiple assignment trick in order to assign those variable names that would make sense. So for example, if we say area code, comma, main number equals mo.groups, then all we have to do is reference area code in order to get back the area code that was there, and main number in order to pull that out. I didn't capitalize that, so main number. You would get back the main number out of there. Does anybody have any questions on using groups? Again, if you use parentheses, it's going to group everything together. If it has a match on those groups, you will get more than one match coming back. Now, the other thing that you would want to check is, what if somebody typed in a phone number that specifically had the brackets already in it, right? And you wanted to check for something like that. So if we come over here and we paste in this one, we'll notice that this breakdown for this one, let's take this out, dash. You'll see that we're specifically matching on these 3Ds again. Those are in brackets, but notice that we're going to escape that bracket by leaving that slash in there, which means that we want to make sure that we're still grouping this, which is what this green portion does. but this slash here is specifically saying do not, or match that specifically so that we can find whether or not they put it in there. So if we look down here at a number, notice that it does not match to the number anymore. But if we had our parentheses in there, it doesn't match either. Does anybody know why that is? So again, in the first capture group, we should be matching specifically to the rounded character, 3 digits, then the last character. We're going to be matching specifically to a dash, not a dot, and that's why it didn't match. So you have to check your characters up here to make sure you're matching what you would expect. All right, so now we have 3 different groups. We have a match overall, which is this whole thing. We have a group 1, which is this first part, and we have a group 2, which is matching this second part. It means that you would have to do 2 different checks, right? You would want to do the check, the one that has these parentheses around it, or you'd want to do a check that didn't, depending on what you're looking to find. So if you really want to find matches for every telephone number, you're now going to have 2 regex strings to actually search through this. All right. You can also use multiple groups by using a pipe. So for example, if we look at the regular expression of Batman pipe Tina space Faye, will match either Batman or Tina Fey. So the pipe is the equivalent of an or. If you want to match both of those, then you would put and inside of there, and it would be able to match and for that. All right. So if we look here again, regex Batman or Tina Fey, we do a search through this text of Batman and Tina Fey. The first group we get back is going to be Batman. If we do a search again with Tina Fey first, then Tina Fey is going to be returned first. So our text here is and Batman and Tina Fey. We're going to find the first example of either one of these 2. When it finds a match, it's done. It doesn't find any other matches. If you want to find all occurrences inside of there, then you would use the .find all as opposed to search. And we'll talk a little bit more about that in a little bit. So if we look at this next regex, you have bat, and then you have man all through here, which means that it's going to find bat, and it's also going to find Batman, Batmobile, Batcopter, and Bat. So if we pass in text that says Batmobile lost a wheel, it's going to match on Batmobile, and the group specifically is going to be Mobile's the one that it found. Remember that if you want to match specifically on the pipe character, we have to what? Escape it with the backslash. So if you want to match on a specific character that is used inside of a regex string, you have to use a backslash in front of it in order to escape it. All right, some other options that you have available is using a question mark. So for example, if we have bat, whoa, question mark, man, this is going to match on either Batman as a whole, or it has the option of matching on Batwoman. So if we look at the adventures of Batman, it finds a match in Batman. If we do a search for the adventures of Batwoman, it finds a match on Batwoman. So now back to what you were talking about inside of your regex string that we had up here. When we go back to our telephone numbers, we can put a quote around here and a question mark here, which will match either one of those at that point. So if we take this off, take our string off, notice how we are matching on either the full context, or if that first part is prefix wrapped, then we would still match on the second part. That question mark gives us the option of 0 or 1 times, as many times as it's going to get possible. So if we look down here on the lower right, if we want to match 0 or 1 time, then we go ahead and put a question mark. If we want to match 0 or more times, then we use an asterisk. And if we want to test for 1 or more, we use a plus sign. If you want to match for specifically 3, then you use the curly braces with a 3. If you want to match on 3 or more, then you use a curly brace 3, comma, and that will find you at least 3. If you want to find between 3 and 6 of this particular pattern, then you would put curly brace 3, comma 6. So there's lots of options to use inside of regex and writing out regex.
I've only known, like, I'm taking Linux right now, and like, Linux is the only one I know that actually has pipes and the question marks that does the exact same thing.
Very similar to it, yes, when you're doing searching through. Yep. So when you want to use the asterisk or the star, this is going to match in a case of 0 or more of anything that precedes it. So if we look here at Batwool with an asterisk inside of here, it's going to find things in Batman. It's also going to find things in Batwoman. And it's also going to find things in the Adventures of Batwoman. It's going to find everything in there because it's finding 1 or more cases of woe inside of there. In this case, we would only want it to specifically find 1 and not more, but it could if you put the asterisk in. If you want to match 1 or more, then we use the plus sign like I just talked about. If you use the curly braces, you can tell it specifically how many you want to match on. For example, the 3 and the 5 that I demonstrated earlier. In the concept of regex, you can also be greedy or non-greedy inside of your matches. What does this mean? So regular expressions are greedy by default, which means that it's ambiguous situations that will match the longest string possible. In non-greedy or lazy version of braces, this would match the shortest string possible and having the closing brace behind it. So what does that mean? If we look down here at the bottom and we have a regex of ha, and we want to find it at least 3 to 5 times, we search through this string, it's going to return us back the 5 that has all 5 of these inside of it. If we do this with a question mark at the end of it here to show that we want it to be non-greedy, then it's going to find us the first group in there of 3 inside of here. So if we say we're going to want to find matches between 3 and 5, by default, it's going to return us the 5 inside of there if there's 5, not the 3. If we put this question mark at the end, we're going to find that it matches in a non-greedy fashion, in which case it matches the first 3 parts. Again, this can be useful depending on what you're trying to filter out of a particular string. The purpose of regex is usually you have a bunch of data from a user, whether they're typing in their name, whether they're typing in a bunch of phone numbers, whatever, their address, etc. You are trying to sanitize that data to get your regex to match and pull that method out. This can also be useful if you're searching a big document and trying to pull out a bunch of stuff, then you would do this. For example, what you'll do in a future homework assignment. All right, we've talked about dot search, and like this, in this case, would find the phone numbers inside of this string. It's going to find the first one and stop. Instead of dot search, if we use find all, then we're going to find all the different matches in a group, and it's going to return a list. So notice that this find all returns a list, where group or search just returns back a string, or it returns back a tuple of groups. So find all is going to return us a list, and it's going to find all the different ones in the list that it matched to. If we have any grouping turned on, for example, we have those parentheses inside of there, then you're going to find groups inside of here with it being comma separated inside of there. So when you have this grouping turned on, in other words, you put groups in here, then you're going to find these tuples come back, and then we're going to do a search to find every combination of that tuple, which is why you're in a list overall. The reason it returns back a list is so that you also have an index to know that this was the first match, this was the second match, etc. Does anybody have any questions on search versus find all? Should be pretty straightforward. Search is going to find the first occurrence. Findall is going to find all the occurrences and bring them and return them as a list. All right, we talked about /D, which is any numeric digit from 0 to 9. If you use a capital D, it's going to find anything that is not a numeric digit from 0 to 9. Lowercase w is going to look for a letter, a number, or an underscore. Think of them as word characters. Capital W is the opposite. A /S is going to look for a space, a tab, or a new line. You can think of it as a space character, and capital S is going to do the inverse of that. Meaning that if we look for something like this one here, and we plug this back into our regex, and we read through this, it's going to find any character, or any, in this case, I'm sorry, any digit from 0 to 9. The plus sign is going to tell us that we want at least one up to an unlimited amount of times, and we're greedy about it, meaning that we're going to find the biggest one we can find. The /S is going to tell us that we're looking for a white space character of some sort. /W means that we're looking for any word character, the equivalent of looking for A to lowercase z, capital A to capital Z, 0 through 9, and an underscore. Plus sign means that we're going to try to find one or many of those. So if we do a search on something that has a really long string like this here, you'll see that in this value, we're going to find 12 drummers is the first part, meaning that we found a number and we found 1 or 2. So that way we can match on, 6 or 12. It doesn't matter. We just want 1 or 2 to match. Then we say there has to be some kind of white space character. In this case, we're using actual spaces. And then we're saying that there's some letters after that, and we don't care how many letters there are up into the point that it's a non-word character. For example, this comma. In which case, we now have all these different groups inside of here that match accordingly. So if we pull this out and bring it up to 7 swans, again, we have to have our space in there. It would show it accordingly. Now, we talked about having our own character classes, for example, of /T, /W, /S. And again, I know this is a lot of material all at once. You'll want to review this video. You can also build out your own character classes. So if you notice, when we go back here, the square bracket 0 through 9 is the equivalent of /D. So say I wanted to find /D, I could also type in square bracket 0 through 9, and I would also find any digit that's inside of there. If I do a plus sign, it's going to find me any digit, 1 or more of those. What's nice about the square bracket is you can define your own character class. So say you want to pull all the vowels out of something, you could say I, E, O, U, and sometimes Y. You can pull any of those vowels outside of here. It's actually A, right? A, E, I, O, U, and Y. We could pull out any of those. If we wanted to find any specific letters that are not that, then we could put in our exclamation point, square bracket, and we could say that it's not going to be A, E, I, O, U, Y, square bracket. Now that one is going to be case sensitive. It's not an exclamation point that says not this. And the reason I pointed that out is in Python, that's how we typically look at it right now, is we use an exclamation point, and that means not, right? If we want to do the opposite of that, which we will learn here in a second, will show us the opposite. So to do that, we want to have a caret key. And so at the top here, you would do a caret, which on most keyboards is like Shift-6. And that's going to look for everything that's not a caret. Take out of the other parts. And you'll notice when we do this, it's going to find everything that's not a vowel. You can build out some really complex regexes. Right now, we're dealing with some fairly basic ones. The caret, again, says that it must occur at the beginning of that. We may also want to look at the $, and the $sign is going to look at the end of the regex for whatever our match is. We could use the dot, which is considered a wildcard, in which case it will find any character that's there. So if we have .at, it's going to look through this string. We're going to find cat, hat, sat, lat, mat, etc. So you can put a dot in front of something to look for it as a wildcard. Think of it like an asterisk when we do other searches in other platforms. If you want to match everything, you would use a dot star. So in this case, if our regex is first name is whatever dot star, last name is our group of dot star. If we pass it first name Al, last name Swigert, we're going to get Al as the first group and Swigert as the second group. This allows us to match anything that's after it as long as it's touching each other in the line. Anybody have any questions so far? Again, a lot of material inside of there. You can match new line characters, which are your /ins. You can pull those out. What's really nice is you have a shorthand for using dot star, which is called dot all. So if you called re dot all, it's going to search for everything. It's the equivalent of it. These are a review of all those different symbols. Again, I encourage you to go play with this regex tool. It's much easier to comprehend as they give you an explanation, a series of matches, and you can test any text that you want in the middle. All right. We talk about case-sensitive matching. For example, we have RoboCop. We can have all caps. We can have lowercase. We can have the first one. If we want to just find anything insensitive, in other words, we're not caring if it's uppercase or lowercase, we can use re.ignore case or shorthand just re.I, and this will treat everything in here as insensitive to the case. So if we want to search for capitals and lower cases and everything else, we want to use re.I. This one will be important. This will be part of your next homework assignment. So in this case, what we want to do is we found all those examples, but we want to substitute. So this is the equivalent of find and replace within your Microsoft Word. So for example, here we find the word agent, and then we find any word after it. We're going to match on that. So if we do a dot sub, we're going to put in whatever we want to substitute in. In this case, we're going to substitute the word censored. And then we're going to pass in the string that we want to substitute in. So in this case, what the result will be is censored gave secret documents to censored. So anytime it found agent and then a word after it, it removed that, put in the word censored, and then has a new string there. You can do the same thing here where we have agent with a W star, so it's multiple letters. We could also pass in a /W asterisk, in which case we could return these asterisks in here. We have this /1, meaning leave the first character. Then we can go ahead and match these out. The idea is that we can now have an output string from Agent Alice told Agent Carol that Agent Eve knew Agent Bob was a double agent. It's going to asterisk out those names, but give you the first character. You will do something similar to this in your homework assignment in an upcoming homework. It won't be till after spring break. All right, you can do really complex regexes as I talked about before. So if we look at this really big one here, this one's kind of long and hairy. It's rough to look at, right? There's a lot of it going on. So in this case, we're going to be matching specifically for different things. And if we look over here on the right, we can see what's in the first capture group. So for example, we're going to be trying to find this different text here. If we go back here, what's nice is you can use R and then 3 quotes, which means you can then break these out on a per line and give us a inline comment. So in this case, we're trying to find something that has an area code, as a separator of dash or space or period. We have a first 3 digits that we're going to find in group. We have the separator again and the last 4 digits. If we want to match for any kind of extension that's in there, we also have this last part that's going to work for either finding the word EXT, the letter X, or EXT period. And then we're going to match based on digits from anything of 2 to 5. So extensions that have 2 digits up to 5 digits. When we do something like this, we have to pass in re.verbose. So when we do a really complicated one like this, it's going to find phone numbers, but it doesn't care whether we use spaces. It doesn't care whether we use parentheses inside of here. Notice that we at least have to have something inside of there. So if we have spaces again, that's going to match. If we do it like they do in Britain, they typically use periods. We can see that it's going to match to any one of these cases. So you could use multiple regex strings, or you could write a really advanced regular expression up here at the top. Obviously, this is the better way to go. It's going to clean and sanitize ones that only have that way. You can also combine most of these re cases. So for example, in this one, we have foo. We're going to ignore the case, or we're going to ignore everything after that, which means we're combining the .all. We could also pipe in ignore case, .all, and .verbose to make sure that it matched. All right, with that, I encourage you to go through and do this project here, which is going to take you through NumPad and kind of match a few things out. That will really get you some more explanation in there. Another one that's really good is this strong password detection. This used to be a homework assignment, in which case I had people build a strong password detector. The idea is that you would write a function that uses regular expressions to make sure that it has at least 8 characters, uses uppercase and lowercase, and has at least 1 digit. So this is a really good one to test and make sure that you understand regular expressions. It's not, you can write it really complicated and then you can go back and clean it up inside of there. It all depends on how you want to write this. So say, for example, we started on this one. All right. So we're going to write a function that uses regular expressions to see if it's strong. A strong password is defined as the following. It needs to have at least 8 characters, contain both uppercase and lowercase characters, and has at least 1 digit. And you may want to test this against multiple regex patterns in order to validate the string. So if we start this, what's the first thing we have to do? Import re, right? All right, now we're going to create a function that's going to use regular expressions to test this. So we call it def, call it password checker, or whatever you want. We're going to pass in some kind of password. And then we need to start doing our checks to make sure it's right. So if we want to set up, first of all, just to make sure that we're getting 8 characters, how could we test for 8 characters or more? Yep, that's a good choice there. So what we need to do is set up our regular expression. So we're going to call this one our length equals re.compile. Our regular expression is going to look like /w with a what? How do we say 8 or more? Does anybody remember? Yep. We're going to use our curly brace. We'll say 8, comma, and then leave the back half open. That will tell them that we want at least 8 word-based characters at that point. All right. Then we need to do a search through whatever our password is. So we would say mo equals length dot search. And we're going to search through our password that we passed in. Now we need to make sure that we got some kind of result, right? So if mo.groups, then we can go ahead and continue on with the next search. If that does not work, in this case, that's what we're going to do here. If not mo.groups, then we can print password failed length requirement. And then we can just return at that point. So you have a couple different ways of writing this function. We can write it where it's going to tell them all the things that didn't match, or we could tell them one by one what they failed. So if they didn't even match the length requirement, we could just end the function at that point and return back to the user. Or we could keep going on to find out whether or not they missed other parts of that, which is what we're going to do in this case. So we have our length portion. Now let's take a look at making sure we have both uppercase and lowercase characters. So how could we split that up and just say, how do we look for uppercase characters? So we would take our uppercase, and we'd say re.compile, R, and then what do we need to have in here? Remember that we could use a square bracket to define our own grouping. So in this case, we want to find all uppercase, which means we are looking for at least one character from A to Z, and we need to have at least one or more of those. Does anybody remember the symbol we use for one or more? Plus sign, right? So very simple regex there. We're simply going to check to make sure that it has at least one uppercase character. So we continue here with our mo again. We're going to search through our password. In this case, we don't want to use length. We actually want uppercase. We're going to use that regex. And if not mo.groups again, we can say print password does not have an uppercase letter. Okay, we would do something very similar for the lowercase. What would we change? A and Z, right? Okay. All right, we have uppercase, lowercase. Now we need to check to make sure it has at least one digit. Anybody got any ideas? What would our regular expression look like? So the first one we checked to see if there was a certain number of letters, right? How do we check for a certain amount of digits? /D, and we need at least one, so plus, right? Okay, copy something similar to this bottom part. And in this case, does not have a digit.
Before we get too far, I want to change the second uppercase to lowercase.
There you go. Okay, so now we have this nice little test. Everything's going to go through. We will get this to print out if it goes through here. So in this case, let's just say we return. Let's have a simple thing here of password equals input. And then we're going to call our password checker. With the password that we have them type in. So if we run this simple little program, it's going to ask us for a password. When I type that, we come back here to password failed the linked requirement. And then we come back on the test of whether or not line 37 which is where we called it, coming back to line 20 here, right? This doesn't find, so we can't use if not mo groups because there is no groups if it doesn't find a case. So what else could we search against here or do our no against? We could just turn this to mo, right? See if we get anything back. We don't want to specifically necessarily look for just the groups. Let's try running that. Okay, so this time we passed our linked requirement, we passed our lowercase requirement, but we're missing an uppercase and we're missing a digit. So if we rerun it, we'll notice that it returns right away, but doesn't say whether or not we matched it, right? So we need to have some kind of case in here as to whether or not this all passed. And you would have to rewrite your function accordingly. There's also a way that you could write this in one big long regex, like what we did here with this advanced regex up here, right here, when we did our complex one, we could write something very similar that would have all of those same checks inside of it. Another way to do that to help clean up this code, notice how I'm pretty much repeating this process over and over, right? If I actually defined these individual regex compilations here and took out this digit and I took out my lowercase, I can now write a very similar loop to loop through those and say I put those in a list. Length, uppercase, lowercase, digit. I can now go through for check and checks and go through and run the same kind of test. The problem with that is I don't know what my test is, and therefore I can't give you back this good feedback. So I'd have to have a better way of doing that loop, but there is a way to do that. Yeah.
You make a Boolean variable at the beginning and set it equal to true for like it's secure password, you know, and then at any of those checks, if it fails, set it to false.
Yes. Yep, you could absolutely do that. If you want to give feedback to the user as to why it failed, you just have to write it in a little more advanced way in order to give that feedback, which is my intention here. So my intention would be that, yes, we wrote it and it works, but now go back and see if you can clean this code up and make it even smaller yet. See if you could write it to where you're not having to go through mo, search through it, find the text and do all that. See if you can shorten this down to a couple lines.
Question.
Yep.
For Python, when, for example, like when it goes through and checks if it has the characters, does it set that value as true or false?
Set what value is true or false?
Like, so like checks if there's 8 characters or more. Does it set?
You're talking about the curly break at 8, comma?
Yeah.
Right. I mean, it basically matches to find out that there's 8 things together. If there's a match, then it returns the match. If there's no match, then you don't get anything back.
I was just wondering.
It's not a Boolean true or false. It's doing a search through it.
You could like set that stuff in like if else statements.
You could, but you would just basically be finding out whether or not Mo exists at that point.
Well, that's what you want to do if you want.
It's essentially what I did, right? If not Mo, then it does the search, sets up Mo. If Mo gets returned, great. If it doesn't, then
Well,
it
yeah,
looks.
but to set it up so that it prints out also what the person's missing in their password.
You could.
So like if length it's like false or not right, it would print out you're missing the character length and so on.
You would have to find a way to match that up. Yes. So you may want to use, like there, I used a list of the different things. Maybe you want to use a dictionary instead. Right? If I use a dictionary and go through all the keys and find all the values, then I could go through and loop it, but I could also give you back feedback as to why that failed on what it failed on. There's a bunch of different ways to do this particular problem. That's why I wanted you guys to go through that exercise. All right, we'll see you on Wednesday for review.